Now we have the last part, and that is spheres and the child of sphere, spheres and hemispheres. Let's take a look at them. Sphere is the three-dimensional extension of a circle, right? Football or any round shape thing that you can imagine. So this is the center somewhere in the middle. This is R. You see, this is also R. This is also R. All these lengths are R, anywhere on the surface, right? For sphere, the volume is very simple formula. It is calculated with the help of integration. The volume is 4 by 3 pi r cube. The total surface area, in case of sphere, everything is curve only. So the total surface area here is the curved surface area only curve. There is no plane surface. And that also is calculated with the help of integration, with the help of solid angle and all. We don't need to get into the details of that. It is 4 pi r square. Okay, this is sphere. Now, what if I cut along this circle? If I cut this sphere, please pay attention. If I cut this sphere, what will happen? I'll get two hemispheres. Okay, I'll get two hemispheres. So don't make a mistake. You will get two hemispheres, obviously, right? So this upper one is here and this lower one is here, right? So these are the two hemispheres. Okay, let's talk about one of them. The radius is the same, r, but you see this is a circle. This is a plane circle, right, of the radius r, and the rest of the things are half of hemisphere with radius r, half of sphere with radius r. So how do I calculate the volume of hemisphere? So volume of one hemisphere is calculated simply as half of this. So it is 2 by 3 pi r cube. But when you calculate the total surface area of one hemisphere, total surface area of a hemisphere, that will have two parts. It will have a base, plane base, plus the curved surface area. I hope you can see that. Okay, plane base is very simple. It is a simple circle with radius r, so pi r square. And the curved surface area is simply the half of the original curved surface area, which is this one. So it is 2 pi r square. So interestingly, it is 3 pi r square. So how would you answer? What is the percentage change in total surface area when a sphere is cut into two hemispheres? What should be the answer? Okay, I want you to try it yourself. The correct answer is 50% increase. Pause the video and try it yourself. Okay, you will get two hemispheres. So the total surface area will be 6 pi r square. Original was 4 pi r square and this is 6 pi r square. So answer would be 50% increase. I hope you can see that. Okay. Now let's talk about some combination of solids which are important for us. Okay. First, I like to describe the word inscribed. Inscribed means completely inside, but exactly inside. Okay. I wanted you to be able to imagine a situation. All of you have seen the ice cream cone. Okay. If I want to put a tennis ball into this, will it be possible? If I want to put that glass ball, that kancha, or the ball used, marbles used in Squid Game, what will happen? Or if I want to put a ping pong ball, what will happen? Okay, so just try to think. Will this be able to inscribed? Will we be able to, put the tennis ball exactly and completely inside the ice cream cone? The average general ice cream cone that we all get, that is almost a fixed size everywhere, right? So try to imagine. Can I put this inside this completely? No. What will happen to this? Oh, this will go completely inside. This will go somewhere here. Right? This is that marble, glass marble, right? But this ping pong ball, the chances are, I'm not saying exactly, but if you can imagine, it will just exactly touch the top surface and also the side walls, and it will fit inside like this. If you can imagine that, that would be very interesting to do. So this is the situation of inscribed. So completely inside and just exactly inside, not inside like in the well, okay, just touching the top surface, okay. Nothing should be coming out, nothing should be spilling over kind of. So this is what I'm talking about. Now let's take certain situations. I'll take one by one. If I have cube inscribed in a sphere, in fact, cube or cuboid, both, or cylinder inscribed in a sphere, how do you interpret? Inscribed in a sphere. Okay, right? Now, first of all, is it possible? Yes, it is possible for all three of them, right? Cube, cuboid, cylinder, they all can be inscribed in a sphere. What is the logic behind it? You just need to remember the relation of the dimensions. We are trying to find the relation of dimensions. Okay, this is very important. Now what is you have to remember is the body diagonal of any of them, body diagonal, okay, of that cube slash cuboid slash cylinder, this should be equal to diameter of sphere. Diameter of sphere. Okay. Now what is the meaning of body diagonal? That body diagonal is the longest distance between any 2 points in that solid. Longest distance between any 2 points in that solid. So if you are sitting in a room, look at your back left bottom corner, back left bottom corner, and look at your front right top corner, the distance between those 2 points. Again, I hope you can imagine that. Just to help you a little bit, I can draw a situation. If you see in this cuboid or cube, this point and this point, or this point and this point, or this point and this point, the distance between any of them, that is the body diagonal, and they will all be equal. Okay, and the length of body diagonal in case of cube, it is simply a root 3. In case of cuboid, it is the extension of rectangle diagonal, that is root of L square plus B square plus H square. In case of cylinder, in fact, you should be able to do this calculation on your own also. It is, you can just check that for cylinder. This is the distance. So this is H and this is 2R. So square root of H square plus 4R square. Right angle triangle usage. Fine. So this body diagonal is equal to the diameter of the sphere. So diameter of the sphere is equal to 2R. Okay, RS is the radius of sphere. 2RS is the diameter of sphere. So radius of sphere is equal to a root 3 by 2 for cube It is equal to root of L square plus B square plus H square by 2 for cuboid. Okay. And it is equal to root of H square plus 4R square by 2 for cylinder. Right. So this is the situation. Okay. Now, let's look at the situation of other way around. What do I mean by that? If I have sphere inscribed in now here I'll take one by one cube. Is it possible? Yes. How? You see, this is the situation where it will look like something like this. Okay. This is not very difficult to understand. Right? The side of square cube should be equal to, the edge of cube should be equal to 2 times radius of sphere. So radius of sphere is side divided by 2. That's it. Cuboid. Is it possible in a cuboid? Is it possible to place a sphere inside a cuboid? Not possible. Right? In fact, when that cuboid becomes cube, then only it is possible. Or if it is possible to place a sphere inside a cuboid, that means it has all the sides equal, and so on and so forth. Whatever way you want to apply, you can do that. So not possible for unequal edges. If all the edges are equal, then only it will be possible, and hence that cuboid is actually cube only. Okay, if it is possible. And the third one, cylinder. In case of cylinder, again, it is not always possible. It is possible only if the height of cylinder, if this is the cylinder, if you can imagine, if the height of cylinder is equal to 2 times the radius of base, and the radius of sphere is also equal to the radius of base of cylinder. Right? I hope you can see that. So possible only if radius of sphere is equal to radius of cylinder, and it is equal to half of height of cylinder, then only it is possible. Otherwise it is not possible. Okay, very simple situations, very simple relations.